plus legs squared. That's just going to equal n squared. Well, that's going to be 49 plus 196 equals n squared. That will be 245 equals n squared. I'm going to take the square root of both sides, and this is where a calculator comes in handy, because who knows what perfect square goes into 245? And who knew it just offhand? Yeah, use your calculator, right? Mm-hmm. That's why it's a good thing to use your calculator. So what is it? What is the perfect square?
49.
It's 49. How many times does 49 go into it?
5.
5 times. So it'd be square root of 49 times the square root of 5 equals n. Well, that's going to be 7 square root of 5 equals...
Would that be the square... Wait, I thought the square root was like when it's the thing times the itself. It's
thing times itself is the number. Maybe because I kind of skipped a step. Maybe that's what you're talking about. That I should have did 49 times 5 equals n.
Wait, what is a square root? Wait, isn't it like when you multiply like 3 times 3 and then that's 9 and then 9, like square root of 9 is 2. But then like, wouldn't it not be the square root because it's 49 times 5, not 49 times 49?
Well, it's square root of 49 times the square root of 5 equals n. So we just have to ask ourselves, what's the square root of 49? So what number times itself equals 49?
Oh, wait. Oh, I thought you were asking about the square root of 2.
I was, but we can't take the square root of 245. It's not a nice even number. If you plug that in a calculator, you can come up with some decimal.
Okay.
But we can simplify it like we did in that first lesson, where I break it apart into 49 times 5, which is square root of 49 times the square root of 5.
Yeah.
Because the square root of 49 is just 7. Because 7 times 7 equals 49. It's one of our perfect squares. So that's going to be 7 times the square root of 5 equals n. So n is going to equal 7 square root of 5. So we're just simplifying that. All right, does that make sense now? I am not going to go through that other problem because it's just a normal Pythagorean theorem, but you should have got 30 out of it. As a quick reminder, remember I pulled bell work questions up for a reason, and those of you that pay attention and study bell work, you'd realize that a lot of them show up on the test, just different numbers, but the same. Sometimes they're even the same numbers. So if you pay attention during bell work and you understand this stuff, you'll know several of your test questions. I say that all the time, and people don't take me at my word, but I do. All right, first thing first, questions on the homework. We're going to go through them pretty rapidly. Yeah? 17. So 17 says the diagonals of a rhombus have length 16 and 30. Find the perimeter. So the big thing is, what in the world is a rhombus? Yeah. It's like a diamond. But what's important about all 4 sides? They're congruent. Well, that's kind of the important part. Hang on, I still want to go through it because it's a good question. So our diagonals, they gave us the length of our diagonal. So this is a diagonal, this is a diagonal. And not only, well, it doesn't look like it, but not only do the diagonals create a 90-degree angle, but what else do we know about the diagonals of a rhombus? What was that? They bisect each other. So that means this length is the same as this length, and this length is the same as this length. So if this total length is 30, what's half of 30? 15. So this length's 15. This length is 15. And I don't remember the other length. What was the other length? What was that? 16. So that makes this 8 and 8. 8 and 8. And Mary, is that enough for you to get this side? No, I love that question. No.
Oh, past that, I couldn't get it. I got like 309 equals x squared, and I couldn't find anything that goes into 309.
309?
It's still number 17.
It's still a number 17? All right, 17 you should have came up with 8 squared plus 15 squared equals 289.
Oh, okay.
So x equals 17. I think you just probably did a little
Yeah.
math error. Go. Questions, keep firing away. Keep rapid fire. 7. Number 7. So we should have had 4 squared plus 4. We should have had 4 squared plus 4 square root of 3 squared equals x, correct? Well, 4 squared is 16. Well,
Oh yeah, that's right.
just remember that this is just 4 square root of 3 times 4 square root of 3. I'm just going to go through the steps really quick, which is the same thing as going 4 times 4 square root of 3 times square root of 3. Well, that's going to equal 16 times 3. Are you good from there? Okay, cool. Questions? Rapid fire. Let's go. More questions? Yeah.
Number 22.
Number 22. Number 22. Let me get the picture. All right, 22, we're supposed to find the value of x given that we know 8, 6, and 8. Uh-oh. Uh-oh. So I have an isosceles triangle, right? And I have an altitude. So an altitude in an isosceles triangle is also bisects this line. So this is in fact congruent to that. All right. So all we would do is 6 squared plus 1/2 x squared equals our 8 squared. Does that make sense?
Yeah.
Okay. Good. Yeah. 12? Did I just do 12? Number 12. I gotta take a picture of it. Rapid fire pictures. Oh, so 12. Well, I know this is 9 degrees, right? 45 plus 45. But it doesn't really help me because I don't know this hypotenuse and I don't want to find this length. It's kind of a waste of time because it's not even going to help me at all. So instead of finding this length, I'm going to look at the fact that this is x and this is lex. So these are the same exact length, right? If this is 2, this is 2, which makes this an isosceles triangle, which means that if this angle is 45, Peter, what is this angle? 45 as well. So that's 45 degrees. If this is 45 plus 45, I believe that's 90. That means that this angle right here has to be a 90-degree angle. And guess what? Now I have a right triangle where I have the sides are x, so I'd have x squared plus x squared. That's going to equal my hypotenuse squared. Is that far enough? Do you want me to go further?
No, it's
You sure?
yeah.
You want me to keep going?
Yes, please.
Okay. So if we have x squared plus x squared, well, why are you telling me what to do if you wanted me to continue?
Is the 6 radical 2 the length of the line?
Yes.
Oh.
So
okay.
6 radical 2 is
Never
this
mind
length. Maybe that was confusing too.
that. Yeah, I thought that was an angle.
No. That is the length of the line. They just didn't have room.
Okay, I get it now.
You sure?
Yeah.
Okay, you're good? You weren't good that first time, I don't think.
Where did you get 2x?
X squared plus x squared equals 2x squared. Alright, so if I continued the next step, that would equal, well, 6 times 6 is 36, times square root of 2 times square root of 2 is 2, and we'd continue from there to solve for x. Are we all good on that? Please tell me if you're not, if you're just like, where did he get those numbers from? I hate this class so much. Why is he such a jerk? Anything like that. Alright, rapid fire. Questions. Mary.
24.
24, that's a good one. That's the one I was waiting for. I think I already have that one taken a picture of. I do. Awesome. So 24. What's great about 24? It's subtly confusing. Just subtly. And what I mean by that is they want this entire length right here. Well, if I just go to basics, and I don't know anything about triangles, I at the very least know that this is 90 degrees, so this must be a rectangle. So this length right here must be 10. Well, if we look at, I have a leg of 12, a hypotenuse of 15, leg of 12, a hypotenuse of 15. So I really just need to solve one of these triangles because the other one's going to be the exact same. Well, this is just a right triangle. I'm not going to call this x, I'm going to call this y, this length y, because x is that total length, so I'm just going to call it y. Alright, so we would have leg squared, so 12 squared, plus other leg squared, y squared, equals 15 squared, and then we solve for y. Okay? So I'd solve for y and I get that length, and I would add that length plus 10 plus that length again, and you get that total length. Does that make sense, Mary, or do you want me to go further? Okay, good. Other questions, real quick, I might have time for one more. Alright, I don't have time for one more then. If you have other questions, please come see me and ask questions on these. Alright, because now's not the time to not understand the Pythagorean theorem, because it just gets harder with it. Alright, the first thing I'm going to talk about is a diagonal of a rectangular prism. We're not doing an example. And the book has pictures of it. I just kind of want to show you where those pictures came from just so you understand it. If I'm given a diagonal from here to up there, I'm actually creating 3 different triangles. I'm creating 3 different triangles because what you're going to do, if it doesn't do it for you, is you're going to put a dashed line right underneath that angle. Alright, so you make a 2-dimensional line. Alright, we create a 2-dimensional line, and I'm going to call that E. Alright, so if the book doesn't put that line in it, you're going to put it in there and just know that's how I'm going to work with this. Because the Pythagorean theorem only works on 2-dimensional objects. We can apply it to 3-dimensional objects, but we have to go through the route of 2 dimensions. So if we look right here, I created, let's do it in light purple. I have this triangle right here, which I can write down over here, and my bottom would be E, C, D. So now I have a 2-dimensional triangle that I can pull right out of there. That means if I knew C and D, I could definitely get E, which could help me get other angles, because if we look at that very bottom, let's do that in red. I have this nifty little square down here that is 2 dimensions. That is way too big. That got away from me. Alright, where we have length A and B, but we got to remember that E is running down the middle. So let's say they give me D and C, right? They give me D and C. I could solve for E, and then I could use E in this drawing to help me find A and B. So you may have to use, and in fact you're going to use, both triangles pretty much at the same time. Alright, you may solve this one first to get back up to this one, but just realize that E is the exact same in both of these. So as soon as you find this E, it's the same one down here. As soon as you find this E, it's the same one up here. It's just applying it to a 3-dimensional space. Alright, like I said, we're not going to do an example. They do kind of an example in the book. So I don't do an example on top of an example on top of an example. I think we can figure it out. Alright, so that's our diagonal of a rectangular prism. I'll leave it up for a couple more seconds. See if people are still. Remember, I might not put every single note you need up here, so if I say something that resonates to you, write it down. Alright, the last one we're going to do is a seemingly easy problem. Oh, I'm sorry, Sam, did you want this still up?
Oh, no, it's okay.
You sure?
Yeah, I got it.
Okay. Remember, always yell at me if I move too fast. And you're just like, I'm still writing that down, man. Slow down. Seemingly easy problem. I got this nifty little right. Oh man, that must mean I have a right angle on the other side. Oh man, this must be easy. I got 2 right triangles. How hard could it be? But wait a minute. I have 2 right triangles, right? I have this right triangle. I have this right triangle. Pythagorean theorem says that I need this segment. And how long is PQ? Okay, how long is QR? We don't know, right? So that's where we run into a little bit of a roadblock. So what we're going to do is we're going to say, well, I don't know the distance from P to Q. So I'm going to call that guy X. I don't know what it is. I'm going to call it X. If I can, I can't always do this, but if I can, I want to write QR in terms of X also, because I don't want to introduce new variables unless I absolutely need to. Is there any way to write that little segment in terms of X, Mary? 21 minus X, perfect. So this little segment is 21 minus X. Well, it still looks, I thought that was actually on your t-shirt for a second. I thought you actually had a Brookfield Academy shirt. I'm like, I never saw one of those. All right, so we have 2 triangles. Let's solve them the best way we can. All right, using the numbers that were provided. Let's not just get stuck and say, I don't know what to do with this. Let's look at this triangle first, that little one. So let me highlight the triangle I'm using. I'm using this triangle right here. Ah, that didn't show up. Let's use red. So I'm using that triangle right there. Okay, so that triangle right there, if I use the Pythagorean theorem, well, one of my legs is h, so I'd have h squared. My other leg is 21 minus x. I'm going to square that guy, and that's going to equal 13 squared. All right, you can either do this work in your head, above, or below, but we need to square that 21 minus x. And I'm going to do it above so we can kind of see the steps that I'm doing. So I'm just going to put a little note up here that, hey, 21 minus x is actually squared is 21 minus x times 21 minus x. Now I don't care how you do it, if you FOIL, I always just distribute. I distribute. So what I mean by distribute is I need to make this 21 go to this 21. Well, 21 times 21 is going to be 441, yeah. Is 441. Well, that 21 also has to go to the x. Well, that's minus 21x. I'm done with that 21, so now I have to go underneath and do the negative x to the 21, which would be negative 21x. And finally, the x has to be distributed to that last thing. Well, negative times a negative is a positive, so I have positive x squared. Like I said, I'm okay if you do it in your head. I'm okay if you write it out. All right, writing it out is sometimes nice because then if you make a mistake, I can at least see what you did. I can't simplify h squared, so that's still h squared. And I'm just going to change the order just a little bit. I'm going to put the x squared out front. I have minus 41 x's, so I can combine like terms, plus 441, and that's going to equal my 13 squared, which is 169. Yes?
Wouldn't it be minus 42x?
Yes, it would be minus 42x. You are 120% correct.
Cool.
That's a lot of percent correct.
Can I get that on my test, please?
No.
Um,
So minus 42x, because 21 plus 21 equals 42. Not 41 turns out, oddly enough. All right, anyone confused at what I did here? Now's the time to ask. Most of it was just algebra, right? It was just me saying that this is x, and this is 21 minus x, and then we just roll from there. Well, I can't do much about this, because I have two variables. I don't feel like solving for a variable until I know which variable I want to solve for, or what I want to do with it. So all I'm going to do is I'm going to set this up, say I have two variables. I'm not going to solve for either one of them. I'm going to see what else I can do. Well, what else I can do is I can look at this other triangle. I got this other triangle right here. So I have that other triangle right here. Well, that's also a right triangle with legs h and x. Well, this one's a lot easier to write because it's just h squared plus x squared equals 20 squared. So we just have h squared plus x squared equals the big old 4 hundo. There's a very clever thing we can do here. I have two equations. What could I do next? Mary? I can absolutely substitute. What would I need to substitute, or what could I substitute? You could do h squared or x squared. So if you're going to solve for one of them, I'd probably choose h squared, because that way I get rid of a whole variable. If I do x squared, I still have regular x, and I have regular h. So if I was going to solve that way, so one way to do this is one way, is I could say h squared equals 400 minus x squared, and this is totally doable, where I throw that in for my h squared. There's something else we can do. There's something else we could do without solving for just one of them. Mary, do you have an idea? You could, yep. That's another way we could do it. Or we could use elimination. There's something a little bit...
Since h squared plus x squared equals 400, and there's h squared plus x squared, you can just put 400.
So Mary, your way would work 100%. 100% we'd come up with the exact same answer. It would just take an extra step. But what we can notice, and this is totally doable, is look at this h squared plus x squared. And you didn't have to notice that. You could have, like I said, solved for that h squared and you would have came up with the exact same answer. But we save a little bit of a step to notice that I have h squared plus x squared. I have h squared plus x squared. Well, this equals 400. So this must also equal 400. This is doable. All right? You can replace, as long as it's exactly the same on the left-hand side as over here, I can replace it with that 400 guy. So let's just take that 400, and I'm going to plug that in here. So that's going to give me 400 minus 42x plus 441 equals 169. Well, if I combine like terms, we have 42x plus 841 equals 169. I'm going to subtract 841 on both sides, and that's going to give me negative 42x equals negative 672. Divide both sides by a negative 42, so that becomes a positive 16. I did it both ways on here. Mary, yours is only like one extra step, maybe, and you could do it in your head and cross stuff out. So at the end of the day, it's probably almost about the same amount of work. So don't be one of those, oh, I never saw that. I'm never going to see that. Just solve for h squared and just do it that way. So now I know x equals 16. I'm done, right? I'm done, right?
Mhm.
Oh. Oh. I need to find h, don't I?
Mhm.
How do I find h if I know x?
Wait.
You do 21
Yeah.
minus x and x equals 16, so 21 minus x is
Say that again?
so like instead of like you could to find QR so you can find h.
We could just do
21 minus x and x is 16, so QR is 5.
so if we do well we know that. I'm worried about h though.
Yeah, and then same with a squared.
Oh, there's one other method we could do. Chris?
Just do 20 squared plus 16 squared equals h squared.
20 squared.
It's like a squared plus b squared.
Oh, yeah.
C squared on top.
Oh,
Yeah, it all goes to the same idea. We're gonna
well you could just put in 16 for x squared.
I could put the 16 in for that. They're all the same. They're going to come out to all the same thing. What I generally do is if I substitute, I just throw this back in for the x. But it's the same. We'll have the exact same number as a squared plus b squared. And in fact, it probably isn't any more work to do it the other way, but we'll do the 16 squared equals 4 hundo, which is going to be h squared plus, what is that, 1? Oh, I just did the whole thing. Yeah. I just shortcutted it into 400 minus 16 squared, which is going to give me h squared equals 144. I take the square root of both sides, and we'll have h equals 12. So it's a lot of steps, but most of it's just algebra. It's just working your way down, whittling your way down. And people gave me lots of good